right, so what do we call it when you have one fraction set equal to another fraction? It is called a proportion. Good. So, what did I teach you to solve a proportion? Cross multiply. So, we could do like 10 times 4, which is 40. Actually, I'm going to write over here. 40. When I cross multiply the other direction, I want to multiply 2 times both a minus 3. So both things. So what am I going to use to signify that 2 is multiplying by both pieces? Parentheses. So 2 times a minus 3. So what will I do next? Distribute. So we'll get 2 times a, which is 2a. 2 times negative 3, which is negative 6. What do I do next? Add 6. So 46 equals 2a, so a equals 23. All right, so we just keep doing that. We're going to cross multiply. So again, 8 times k plus 6. Cross multiply the other direction. 6 times 9 is 54. It's okay. It's all right. Distribute. We're going to have 8k. Here's your redemption, Bryce. What's 8 times 6?
Oh, 86. 48. 48.
He was just playing, guys. Equals 54. We're going to subtract 48. So on the left, all we have left is 8k. On the right, we have 54 minus 48, which is 6. My last step is to divide by 8. We are going to leave this as a fraction. Can it be reduced? Yes, to 3 over 4.
So we have that as a decimal, you didn't mark that wrong.
I'd rather fractions. This one I wouldn't necessarily, but on the next one, it's going to be a repeating decimal. I would, like if the bottom number, the denominator, is 3, I would especially leave it as a fraction, because you'd be rounding at that point. I do prefer fractions. And the main reason is, I'm going to guess you plan on taking the PERT. No, maybe not. Either way, has a lot of fractions on it. So we're practicing the PERTs at the end of next month. So all right, we're going to do the last one. We're going to cross multiply again. The only difference, does it matter what order you multiply in? It does not. Meaning like 1 times 2 is 2. 2 times 1 is still 2. So here's what I'm telling you. This is technically n plus 5 times 7. Do we like the way this looks? Not really. If you do, then cool, keep going. I like the 7 out in front. This is the same thing. I didn't change anything. I just made it look a little different to where I liked it better. We're going to do the same thing the other direction. N minus 9 times 4. I'm going to say 4 times n minus 9. It's just a little prettier to look at. We're going to distribute on both sides. So on the left, we'll have 7n. What's 7 times 5? 35. On the right, we have 4n. What's 4 times negative 9? Negative 36. I'm going to move my smaller n, which would be 4n. So 3n plus 35 equals negative 36. What do I do next? Subtract 35. So 3n equals negative 71. My last step, divide by 3. So this is what I meant, Blake. If you plug this into your calculator, it would be a never-ending decimal. So I would just leave it. You're going to keep this paper out. We're going to go back to it in a few minutes. But otherwise, we're going to go to 8.1. Turn to page 4, I think. Pretty sure. Maybe. Nope, 5. Is this 5? Never mind, 4. I lied. Where we left off. So page 4, Los Santo. Okay, so at the bottom of your page, what you're going to do, there's this big blank spot. What you're going to write, we're going to be dealing with perimeters of similar polygons. Before we write anything, what is a perimeter?
Outside.
The outside of something. So what's the perimeter of this room?
The walls.
The walls. What's the perimeter of a yard, usually?
The gate.
A fence. Yeah, it's a gate. So, how do you find the perimeter of an object?
You have to go
Add up the
Sides.
Add up all the sides. Okay, so same idea. What's going to happen is we're going to have two polygons that are similar. So they won't have the same perimeter. They're going to have similar perimeters. Okay? So what you're going to write first is perimeters of similar polygons. You're going to write it at the bottom somewhere. I'm going to show you a formula. So you want to write that. Perimeters of similar polygons. This is on your notes quiz. Remember, you're having one of those. At the bottom of page 4. So you see there's this big blank spot.
But it's a guessing.
So I'm going to say, what is the formula to find the perimeter of similar polygons? And this is where you're going to find it.
What is it called again?
So again, you have to use the sides from corresponding sides. So you would use these two, which are corresponding, or these two are corresponding, stuff like that. Okay, so here's your formula. We're going to use it on this page. Sorry, I had to repeat myself. I was not recording. All right, so here's my shortened version. We're going to take a side from the first, put it over a side from the second, and set it equal to the perimeter from the first over the perimeter of the second. All right, so what do you think is the side we're going to use on the first figure? We can use numbers. Yeah, 10. So 10, which is this side length. Because my whole goal, actually you're going to take your pencils, the two gazebos shown are similar. So underline the word similar. This means their sides are proportional and their perimeters are proportional. We're going to find the perimeter of gazebo A. So do I really need to know anything about X over here? I don't. I really don't. All right, so side from the first is 10. So what side am I going to use that corresponds with that one? 15. Equals the perimeter from the first. Do I know the perimeter of the first one? No, that's my whole goal, is to find that. So normally we would call something we don't know X, but the only issue with that is we already have an X. So I'm going to call it P for perimeter. If you don't like that, you do you, but that's what I'm going to do.
Wait, why are you doing that?
There's already an X in the problem, so I'm just not going to use X. You can use any letter in the alphabet if you want. And then we need to find the perimeter of the second. Do we have enough information to find the perimeter of the second? We do, so someone take out their handy-dandy calculator. How much? Good. So 69. So you can do two things here before you do anything. You can reduce up and down if you want to. It makes your numbers smaller before you cross multiply. We are going to do it later on in the lesson. Would we like to do it now?
Yes.
Okay. So you can always reduce up and down. So what number are both the top and the bottom of this fraction divisible by? 5. So how many times does 5 go into 10? 2 times. And then how many times does 15 go into, 5 go into 15? 3. So I didn't change the value. Okay, this is still worth 2/3. This is worth 2/3. I just made the number smaller. Now I'm going to cross multiply. 3 times P is 3P. 2 times 69 is 138. All right, my last step.
Divide.
Divide by 3. So the perimeter will equal 46. So we need to use the units they used. So what does M stand for? Meters. So 46 meters. Okay. You're going to go to the piece of paper from earlier. You're going to need a little bit of room to write. Basically, the classwork, if you don't finish the classwork today, it goes into homework. 2 of them are the problems we're about to do. Okay, and so is one of them on the quiz, your math quiz next week. Okay, so you're going to write this down on your Chapter 8 extra paper. 2 polygons are similar. You need to write the directions of it. 2 polygons are similar. The perimeter of 1 polygon. So you're writing this on your piece of paper. Yep, you'll be okay. You're already behind everyone else. Come on. 2 polygons are similar. The perimeter of 1 polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon.
Wait, so quiz practice just open notes?
This quiz this week is open notes, but it's no math.
We're gonna be able to look at it.
Yes.
How's it come question?
It's literally a quiz over your notes. So it's can you find in your notes what you need to find. Monday's quiz next Monday. That's actual math.
Yes.
How much do we need to leave in the $2?
It's not much math. It's not much work. So not very much.
Maybe
Like 3 lines is probably fine. I think you write small. Alright, so we're going to do the first one. The perimeter of the smaller polygon is 12 feet, and the scale factor is 3/4. Let's review what scale factor did. The scale factor was a number. What did we do with that number? Multiplied to what? Multiplied to all sides from one figure to make a new figure, right? So they gave us the scale factor and they gave us the perimeter of a polygon. Geometry is much easier when you have pictures. Do we all agree? So pick a polygon to draw.
Square.
We could do square first, and then we could do triangle. Triangle is a polygon, you're correct. We're going to draw 2 squares. One is smaller than the other. Do the best you can. They don't have to be perfect. This is just an example. It's not accurate to our picture, really. The smaller polygon has a perimeter of 12 feet. We don't know the larger perimeter. We do know the scale factor is 3/4. So the scale factor is a number that you multiply. So it's 3/4. Here's the problem. If I took 12 and multiplied it by 3/4, don't write this down, would my perimeter get larger or smaller? Smaller. What do I want it to get? Bigger. Okay, so what do I need to do to 3/4? I need to flip it. Basically, they gave us a scale factor from the larger to the smaller. Okay? We want to find from the smaller to the larger. So we're going to multiply 12 times 4/3. Whenever you multiply a whole number by a fraction, what do I have to do first? Put it over 1. When you multiply 2 fractions, this is not a proportion, because what is between 2 fractions when it's a proportion? An equal sign. Is there an equal sign? No, there's a multiplication sign. So you multiply directly across. 12 times 4 is
48.
48. 1 times 3 is 3. Does 48 over 3 reduce? It does. To 16. So your answer is going to be 16 feet. 16 feet. So hopefully it would have raised a red flag if you got a number smaller. That would not make sense for a larger figure to have a smaller perimeter. We're going to do the same thing here. Nate wanted a triangle, so we're going to draw a triangle. Ooh. You need a smaller one and a larger one. Ooh, that's ugly. Do the best you can. It is what it is. We have the perimeter of the larger, which is 72 inches. So we know the scale factor is 6 over 5. So we need to use our common sense again. If I multiplied 72 times 6 over 5, would my number get smaller or larger? It would get larger. Do I want my perimeter of my smaller shape to be larger? No. So what do I need to multiply by instead? 5 over 6. Put 72 over 1. Multiply straight across. 72 times 5 is 360. Divided by 6, that makes 60. Which is the answer. 60 inches. We're going to go back to our notes, page 5. We're almost finished. Page 5 is it. So you're going to write off to the side. There's this big blank space. You're going to write area of similar polygons. And then the formula is at the bottom. So if two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So you want to write this right here, or did you already write it? The formula's right here. So you're going to take a side from the first, put it over the side from the second, and you're going to square them. And it will equal the area of the first over the area of the second. So what's the only difference between this formula and the last formula?
Square.
Square. Okay, well, I'll remind you how to square a fraction, because we need to. All right, so if you didn't finish writing it down, I have to write it down anyways. Side from the first, over the side from the second, squared equals the area from the first over the area from the second. So, what side did they give me in the first figure? 7. And in the second figure? 21. And it will equal the area from the first, which is 84. And then the area from the second, which we don't know. It's the whole goal. Find the area of LMNP. So we don't know. I'm going to write capital A for area. So, then there comes the task of, what do you think we do next? We square, right? When you're squaring something, what are you actually doing? Multiplying it by itself. So technically, 7 over 21. Sorry, I ran out of room on the screen, I guess. 7 over 21 times 7 over 21. I'll move it for you. Okay, so basically what happens? What's 7 times 7? 49. And what's 21 times 21? Is it 421 or 441? 441. So 49 over 441 equals 84 over the area. So here's what I tell people. So pause if you don't want to write this off to the side every time. I tell people square the top and square the bottom. And it's the same thing. Or you can go off to the side every time and write it like this. Either way, I think it's easier. Square the top, square the bottom, and that makes your new fraction. Now we have one fraction set equal to another. So what do we do from here? We cross multiply. You can reduce if you want to. You can. Up and down only. I'm just going to multiply. But if you know to do that, go right for it. Go for it. So we're going to have 49 times the area. What is 441 times 84? 37,044? So this?
Yeah.
0. Okay. Alright, and then divide by 49. So what do we get as our area? 756. So this is area, so we're going to say meters squared. Area is measured two-dimensionally, right? So they say you can fit this many squares in this area. Okay. If you reduce, did you get the same answer? Yeah, you did. Okay. All right, this is the last two that we do together. The figures are similar. Find the missing corresponding side length. So we're missing a piece of the formula. Number 5, are we going to use perimeter or area? Perimeter, so I'm going to write it in. My shortened version, I say S. What do you think S stands for? Side from the first over the side from the second will equal the perimeter of the first over the perimeter of the second. Just saves you a little bit of time. So do we have a side from the first? We do. It is, 5. Good. So our side from the first is 5. Do we have a side from the second? No, we don't. We're looking for that. So you could write S. I don't like to use S in the middle of a math problem. Can you guess why? Looks like a 5, so I'm just going to put X. So again, you can use any letter you want. I just don't prefer the letter S. Do we know the perimeter of the first? It is, 60. And then the perimeter of the second is 84. All right, so we can cross multiply. X times 60 is 60x. What is 5 times 84? Is it 420? Yes, no, maybe so?
Yes.
Okay. Divide by 60. X equals 7, so we need to use the units, so it's 7 inches. All right, last one. Are we going to use perimeter or area? Area. So same formula, except for what's the only difference? The square. The sides are squared. All right, so what is the side from my first figure? 88. Do I know the side from my second? No. So again, I'm going to put X. Do I know the area from the first? It's 4,928. Do I know the area from the second? Yeah, 77. So again, whenever you're squaring a fraction, you square the top and you square the bottom. So 88 squared, what is that number? 7,744, good. And then what is x squared? X squared. Trick question. And it equals 4,928 over 77. All right, so we're going to cross multiply. So make sure you're ready for me. I'm going to make room for myself. So we'll do this direction. X squared times 4,928 is 4,928 x squared. All right, and then what is 77 times 7,744? You mumbled it. 5,000? No, 5. Yeah, 596,280. It's good. All right, so next step, we need to get x by itself, so we need to get x squared by itself. So what am I going to do? Divide by that 4,928. I'm not there yet. 1 second. What does that make? 121?
121.
Are you impressed? What's the opposite of squaring?
Divide.
It is not dividing. Square root is the opposite of squaring. So square root on both sides. So x equals 11, and we're going to say 11 feet. It is, however, not squared. Because did we find area? No, what did we find? Which is a side length. We found a side length. Okay. You're going to take out your textbook.